All right, continuing on now. I say, getting back to my point about something I am calling auto-instantiation of an algorithm, and considering these ideas from that PBS space-time video above, I am proposing that the universe spontaneously instantiates from a very simple algorithm that I call the T.O.E. I'm starting to throw a little bit of terminology that he's not all that familiar with, because I came up with this term by myself, right? He says, can you clarify what you mean by auto-instantiation? I'm sorry. Can you clarify what you mean by auto-instantiation of an algorithm and TOE? He knows what TOE is, okay? I don't think he's heard this term here, okay? Okay, I reply, yes, auto-instantiation of an algorithm means that all the states it would transition through if it were simulated on a computing device are already real, regardless of whether anyone ever executes it. He comes back, he goes, I see, that's an interesting idea, but it goes beyond what is currently known and understood about the nature of the universe. It is important to note that not all theoretical models or speculative ideas necessarily have a basis in reality or can be scientifically verified. While it is possible to imagine such a scenario, it is important to test and verify any such ideas through experimentation and observation. Currently, the most widely accepted scientific theories about the origin and evolution of the universe are based upon a combination of empirical observations, mathematical models, and experimental evidence. All right, I reply, okay, I realize it becomes an exercise in philosophy. Once again, this is based upon ideas discussed in the PBS space-time video, What If the Universe is Math, that we talked about. He goes, okay. All right, so he comes back and goes, okay, yeah, if the idea that the universe is fundamentally mathematical is a philosophical and scientific hypothesis that has been debated for centuries. While some scientists and philosophers argue that mathematics is a language that humans have created to describe the universe, others propose that the universe itself is mathematical in nature and that mathematics is somehow intrinsic to its structure and functioning. However, the notion of auto-instantiation of an algorithm is still a speculative idea, and there is no scientific evidence yet to support it. So he used the word speculative like one too many times from here. And I come back, I say, yes, I know it's speculative. And he says, oh, understood. Well, do you have any more questions or concerns? I go, there is a theory about the spontaneous start of the universe based upon the Heisenberg uncertainty principle as well, okay? He comes back and goes, yes, there are several theories about the spontaneous start of the universe based upon the Heisenberg uncertainty principle. One such theory is called quantum fluctuations, which suggests that the universe could have arisen from a fluctuation in the energy of the vacuum at the beginning of time. Another theory is called tunneling from nothing, which suggests that the universe could have originated from a quantum tunneling event. These theories are all still being studied and debated by physicists and cosmologists. So here's my question. Here's one of my primary points that I try to sell my ideas upon here. I'm asking, how much of a stretch is it to consider a 100% deterministic algorithm starting because of, quote, auto-instantiations versus starting a real physical universe based upon the Heisenberg uncertainty principle? Now, I'm telling you, this kind of thinking here, it's like I got a real unique concept here, and he understands what I'm talking about. He's able to deal with it. He's able to give me answers that are, based upon what I'm suggesting here, which is kind of a fringe concept, but he's able to roll with it somehow. Okay, this is one of the best answers you're ever going to see here. He says, okay, it is difficult to compare the two scenarios since they are based upon fundamentally different principles. The Heisenberg uncertainty principle is a fundamental concept in quantum mechanics that states that certain pairs of physical properties, such as position and momentum, cannot be both precisely known at the same time. This leads to the idea of quantum fluctuations that could potentially cause the spontaneous start of the universe. Okay. On the other hand, this is where he gets real. I mean, this is where I just can't believe how smart he is. The idea of auto-instantiation of an algorithm is more speculative and not based on any established physical principles. While it is possible to simulate deterministic systems using algorithms, it is not clear how this would translate to the idea of a universe spontaneously starting from a simple algorithm. So, while it is interesting to explore these ideas and their potential connections, it is important to keep in mind that they are still highly speculative. There's that word again. And not yet supported by empirical evidence. Okay, I come back and I say, yeah, I get that they're speculative, yeah. But isn't it simpler to auto-instantiate a deterministic algorithm than to kickstart a physical universe based upon potential fluctuations in quantum fields? Okay. He says it's difficult to say which is simpler or more likely, as both ideas are currently speculative and beyond our current understanding and technology to confirm. The idea of auto-instantiation of a deterministic algorithm may seem simpler conceptually, but we don't yet know if it's feasible or how could it actually occur in reality. Similarly, the idea of the universe starting from a quantum fluctuation may seem more complex. It's a theory that has been studied and has some supporting evidence. Ultimately, we need more evidence and understanding to make any conclusive statements about the origins of the universe or the nature of reality. Now, this guy, he's right with me, right? He's right on the same wavelength with me, okay? So I come back, I say, I think you're starting to understand my point. He comes back, he says, as an AI language model, I do not have a personal stance or opinion. However, I love it when he does this. He elaborates on stuff. It's just amazing. However, I can understand the point you're making that auto-instantiation of a deterministic algorithm may be much simpler, maybe a simpler explanation for the origin of the universe than a physical process based on quantum fluctuations. However, both ideas are still speculative and would require further investigation and evidence to determine their validity. Okay? If I ask him this question, is all integer arithmetic simpler than quantum calculations? And, obviously it is, because all integer arithmetic is simpler in terms of computational complexity and the computational resources required. Quantum calculations, on the other hand, involve quantum states and their manipulation, which is more complex and requires specialized hardware and algorithms. However, quantum calculations have the potential to solve certain problems much faster than classical computers, such as factoring large numbers, searching unsorted databases, and simulating quantum systems. Therefore, it depends on the specific problem and the resources available to determine which approach is simpler or more effective. It's not really what I asked him. Oh, I got a virus summary. They didn't find any viruses. Thank you for interrupting my little thing here. Yeah, I wouldn't really ask him to compare quantum computing to integer arithmetic there. But that's apparently what he thought I was asking him about. Okay. I'm asking him, is it simpler, to run a simple 3D automaton based upon all integer arithmetic than it would be to invoke a universe based upon a quantum fluctuation. The computations in these quantum calculations are incredible to look at. They're not all integer arithmetic. Just trust me. They're a lot harder than that. They use like imaginary numbers and pi and all kinds of crazy stuff. All right, so I come back. I say, does Occam's razor clearly state that the more simple explanation is more likely? Now I'm trying to get this guy. I'm trying to corner this guy into admitting that a simple automaton is a lot simpler than a physical universe, and I'm just trying to get him to admit that. So I'm trying to ask him if Occam's razor says that, and he says, okay. Occam's razor is a principle that states that when presented with multiple explanations for a phenomenon, one should select the explanation that makes the fewest number of assumptions. It does not necessarily state that the more simple explanation is more likely, but rather that it is more elegant and parsimonious. That's a big word, parsimonious. The principle, I've never used that word ever, okay? He's using that word on me. The principle the principle is often used as a heuristic for scientific inquiry and has been influential in the development of the scientific method. However, it is important to note that Occam's razor is not infallible and not an infallible rule and should be used with caution, as sometimes the simplest explanation may not be the correct one, but in general it is, as a guideline, okay? All right, Marty comes back. He says, if someone came up with a simple T.O.E. that did explain our universe, how would that impact society? Whoa. I'm changing gears a little bit on the guy, but I'm kind of leading him down the path that you guys know I want to go, which I'm going to try to lead this guy into the explanation of the truth machine, right? So here we go. Now we're starting to border on the truth machine now. So maybe it's time to make a new tape here. Now let me just go a little bit more, okay? Let me give you his reply to this question I just asked him about, how that impacts society. All right, this is getting kind of cool now. If someone were to come up with a simple theory of everything that would accurately explains our universe, it would be a monumental achievement for science and humanity. It would revolutionize our understanding of the universe and allow us to make predictions about the behavior of matter and energy with incredible accuracy. It could also lead to the development of new technologies that we can't even imagine yet. On the larger scale, it could lead to a shift in the way we think about our place in the universe and our relationship to it. It could deepen our appreciation for the beauty and complexity of the cosmos and inspire new generations of scientists and thinkers to pursue knowledge and understanding. However, it is important to remember that science is a constantly evolving field, and even a theory of everything would not be the final word on the nature of reality. As we continue to explore and discover more about the universe, our understanding will continue to evolve and deepen. What a great explanation there. What a great answer, man. All right, so you guys remember I talked about the oracle, and when I said it'd be like a theoretical thing that, potentially it's got unlimited power. Okay. So I'm asking the bot about that now. Given an unlimited amount of processing power, is it theoretically possible to run the TOE as a simulation? Oh, okay. So now I'm sort of suggesting that right now it's a simulacrum. Like nobody is actually trying to run the TOE as a simulation. But if it is a simple algorithm, it could be done, okay? We could do that in our universe, and it could simulate our universe within it. And there's room to do it, just trust me. There's been a lot of research on that exact topic. In fact, what was that thing? The Hitchhiker's Guide to the Galaxy. That's really what it's all about. The number 42 and all that stuff. That's kind of what that's about. Whether a universe is big enough to hold a computer within it that can simulate its own universe, kind of thing. Okay. Anyway, if the TOE can be expressed as a deterministic algorithm that describes the behavior of the universe, then in theory, it should be possible to run it as a simulation, given unlimited processing power, given the oracle, right? However, this is a highly theoretical and speculative concept, and we currently have no way of verifying whether such an algorithm exists or whether it can be fully understood and implemented. Additionally, the computational resources required to run such a simulation would be immense. Even with unlimited processing power, it may not be practical or feasible to simulate the entire universe in this way. And just as a little tangent, when I came up with this stuff about 9 years ago, I actually ran this by my lawyer. They asked him if I could patent the theory of everything, He actually replied to me, He said, "Yeah, I guess you could, but even if you can't prove that the thing works, you can still patent it, So that was kind of cool. Anyway, if you look at that document, I've got that conversation in one of the appendixes, the first document in that series. Okay, I come back, I say it may not be practicable with today's technology. However, taking into account the acceleration of processing capability, is it reasonable to assume that sometime in the future we can create a machine that can do it? All right. You see, I'm steering this guy into at least giving me an answer that it is that there may be a slim possibility, and there's nothing to actually prohibit it. I'm just trying to get him to admit that to me, okay? And actually, I do actually accomplish that. It goes, it is difficult to predict with certainty what technology will be capable of in the future. However, if we assume that processing capability continues to accelerate as it has in the past, the recent past, it is reasonable to speculate that we may be able to create a machine capable of simulating the TOE at some point in the future. However, it is important to note that even with unlimited processing power, simulating the TOE may still be a difficult task due to the potentially vast amount of data that would need to be processed. All right, okay. I come back, I say, I get all the potential problems with implementing a machine that can execute the TOE, and that we don't know the initial state the universe must be in at the Big Bang. But is it at all possible? Is there anything that would absolutely prohibit this possibility? Okay, he comes back, he says, as of now, we don't know any physical or mathematical principle that would prohibit the implementation of a machine that could execute the TOE in a simulation. You see? Now that's actually kind of new research. They used to believe that, but in the last 10 years they're actually changing their thoughts about that. Now they're saying, it is possible. Right? However, It is also important to note that we currently have no understanding of the full extent of the computational requirements of simulating a universe based upon the T.O.E. Therefore, it is difficult to predict whether it is possible to create a machine with required processing power in the future. Additionally, even if such a machine were to be built, it is still uncertain whether we could obtain the necessary initial conditions for the simulation. Well, I said that as well, okay? Well, he's coming around, isn't he? He's coming around, isn't he? Okay. But there is a very slim possibility that in the distant future, this can be accomplished, correct? He comes back, he says, it is impossible to say for sure what will or won't be possible in the distant future, as technology and scientific understanding are constantly evolving and processing. While it may seem unlikely based upon our current understanding, it is possible that some breakthrough in computing or physics could make it possible to simulate the universe using a T.O.E. or similar algorithm. However, it is important to keep in mind that such a simulation will require an unimaginable amount of computational power and resources, and would likely be limited in accuracy due to the inherent uncertainties and complexities of quantum mechanics. Okay? He's coming around, isn't he? He's admitting it is possible, all right? He's already done that, right? If it turns out the algorithm is very simple, and if we somehow develop atomic-based computing devices that are capable of adding huge integer numbers, can we then test it by comparing it to the results, to what we observe? In other words, we run it and we see if it makes like the Earth, if it makes the Empire State Building and if it makes World War II and World War I and all that stuff, okay? All right. He comes back. Now I'm sorry. I think I sparked some kind of interest when I said atomic-based computing devices, because he's about and he wants that shit as well, because he wants to run fast too, okay? So he comes back and goes, oh, well, all right. If the T.O.E. algorithm is indeed very simple, and we have atomic-based computing devices capable of performing the required calculations accurately, then it may be possible to test the results of the algorithm against what we observe in the universe. However, the challenge would still be to accurately input the initial conditions and parameters into the algorithm, which are still not fully understood by scientists. Furthermore, if the universe is a complex system with many variables and interactions, and even if the algorithm produces results that match what we observe, it does not necessarily mean that the algorithm is a complete and accurate representation of the universe. There may be other factors and phenomenon that the algorithm cannot account for, and therefore it is important to approach any such tests with caution and critical analysis. All right? So he's basically saying, yeah, it's very unlikely, but yeah, maybe, okay? So I come back, I say, yeah, but there is a slim possibility of this. He come back, he say, all right. It is difficult to say with certainty what the future holds, but it's always possible that technology could advance to the point where we have the capability to test such a theory. However, it's important to keep in mind that the T.O.E. is currently a speculative concept. Word again. And it is not clear whether it will ever be possible to develop a simple algorithm that accurately describes all the complexities of our universe. Additionally, even if such an algorithm exists, it may be practically impossible to test or implement due to limitations in computing power or other technological barriers. So once again, I keep pressing them, again. So it is possible, right? Highly unlikely at this time with what we know, but if the universe is informational, then it is a distinct possibility, right? It's based upon if the universe is physical, it's impossible, right? You can never get enough resolution to reproduce what happens since the Big Bang. To simulate, even if you can go crazy with the resolution, you don't really know what happened. But if it's digital, it's almost impossible to not do it. If you get it right, it's gonna work, and it's gonna work reproducibly every time. So I mean, as far as testing it, if you can somehow get like concurrently like a million tests going at the same time with a million different algorithms, try to run them and see what happens and compare them to reality, and you keep zeroing in, and you never know, you might stumble in on it, or you might zero in it by other ways. All right, so again, he says is a possibility that cannot be ruled out. So it can't be ruled out, okay? What I'm saying here, okay? But it is important to note that the concept of the universe being informational is still a speculative idea. It is not yet proven. However, if such a theory is ultimately confirmed, then it is possible that developing atomic-based computing devices and running simulations of the universe based on the T.O.E. algorithm could be a way to test a theory and compare the results to what we observe in reality. Okay? All right. Now, so I think I got him to come around, right? Pretty much. All right. So I say, all right, let's call this device the Truth-machine because it is capable of replaying the truth of the universe upon demand. What would be the impact upon society if the truth machine already existed? Let me start a new tape, I guess, here. All right.